Hello everyone. Today we're going to talk about graphing a quadratic function. So the goal is, let's say you have a function like this, and we know already that the coefficients a, b, and c are some numbers. So the goal is how we can plot that or how we can graph that quadratic function, right? So there are a couple points, very interesting points. First is like we can easily find the vertex point. Basically, the vertex point is the minimum point of any function, or could be maximum point of any quadratic function. And the other point is that this function is always, you can find a mirror that it can basically cut the a quadratic function in half. Basically, this line can be easily found as a mirror line. And let's go into the real example and see how we can graph a quadratic function using a, b, and c as a real number. Okay, right now I have my general quadratic format as a x2 plus bx plus c here. And on right hand side, I have my example, which basically I'm going to compare these coefficients to find what is my ABC. A is 2, B is -4, and C is -6. Just kind of going apple to apple comparison. And here on the left hand side, I have some rules. Rule number 1, 2, and 3. These are gonna help me to plot my quadratic format here. I want to plot this. So the goal is to plot this or this one. It doesn't matter. And I'm going to follow 1, 2, 3, one by one. Starting from 1. Try x0 here. Try x0 in the format. Try x0 in my example, which is 2x2 minus 4x minus 6 equals, I'm going to put 0 on for x, minus 4 times 0 minus 6. This is 0, this is 0. So the answer is for x0, my expression would be -6. And basically, I can say that 0 and -6 is one of the points on this quadratic format, which I will be plotting that point in my xy coordinate, okay? Number two is find the vertex point as this. This is my vertex point, and I will show you what vertex means in the plot later. Let's just figure out what is that. B is -4, and 2a is 2 multiplied 2. So it's going to be 4 over 4. It's 1. So vertex is 1. And I'm going to apply that on the whole quadratic format, and then apply 1 for x to see how much it's going to be. It equals, this is 2 minus this is 4, and this is -6. So answer would be -8. So then for x equal 1, I will have y as -8. This is my another point which satisfies this quadratic format. Point number 3 is find the roots as this. I want to find the roots of the quadratic format. Looks like if I have 2x2 minus 4x minus 6 equals 0, if I put that equal to 0, then I want to see what is x1 and x2, basically the roots. So I'm going to put them here. X1 and x2 is based on this formula, is minus b is b is minus 4 here, plus minus square root of b2, which is minus 4 squared, minus 4 ac 2 minus 6 over 2a. I'm going to simplify that. Over 4. I'm going to simplify x1 and x2 as 4 plus minus square root of 16 plus 48 is 64. So then it's going to be 4 plus minus 8 over 4. So x1 is 3, x2 is minus 1. Okay, so I got the minimum of the, the roots of the quadratic example. Now, if I want to plot that point, let's just have a sample of x1, x and y, and then I will start trying to plot these points and these points here, okay? Let's try this one. This is first point, 0 and minus 6. Let's go, let's say, just imagine this is minus 6. So this is 1 point. I'm going to call it A, and I'm going to call this point A. Just going to make it a little bit different color. Then point B, I'm going to call this B is 1 and minus 8. Let's just imagine this is 1 and here is minus 8. So B was our vertex point. And then I have two other points here. One point is x3, another point is x minus 1. So for x3, for x13, I'm going to put it in my example, which was 2x2 minus 4x minus 6, which is 2, 3 squared minus 4 by 3 minus 4. So the answer would be 18 minus 12 minus 4, which is 2. So another point would be 3 and 2. And for x2 minus 1, I'm going to put it again into the quadratic form, equals 2 minus 1 power 2 minus 4 minus 1 minus 4 equals 2 plus 4 minus 4, which is 2. Another pair is minus 1 and 2. What did I do? Basically, I tried this in the quadratic format, and I got two value for them, 2 and 2. And I'm going to just plot these in the xy coordinate. So first is 3, 2. Let's just pretend this is 3, 2. I'm going to call it point C. And then the other one is minus 1 and 2. Let's try minus 1 and 2. I'm going to call it D. And because based on the fact that my quadratic format was 2x2 minus 4x minus 6, because the coefficient of x2 is positive, so my shape would be something like this, upward. And you know, I have 4 points. I have A, B, C, and D. How can I fit something, a curve, which be upward and passing through all of them. It's going to be something like this. Right? It's going to be something like this. I'm not good at drawing. And remember, this B was driven from here. Point 2. Point 2 was telling us the vertex point. Vertex point is always, if you have an upward curve, vertex point is your minimum point. And if in some example you have a downward curve, vertex point would be your maximum point. Okay, here we have this. Okay, that's how we draw that based on the 3 rules that we have. Okay, right now I have a question for you. Well, before I go to the question, hopefully what I have explained could be helpful and at least made it a couple of steps easier for you to understand how to plot the quadratic formats easier. But anyway, if you have any question, comment below. I will try to get back to you as soon as possible. Go back to my question. If I have a quadratic format as 3x2, let's say minus 2x plus 10, right? This is one example. And if I give you, let's say, 2 plots, just as an example, x, y, and x, y. Plot number 1, plot number 2. If plot number 1 be something like, let's do blue. Where's blue? If plot number 1 is something like this, and plot number 2 is something like this, which one potentially can be the plot for this quadratic format? Well, I know it's a very rough estimate, but there is a difference between plot 1 and plot 2, and that difference, which I'll give you a hint, and that hint is related to this point here, x0. That's the hint about this point. Which one could be potentially a better plot for this one? Okay, comment your answer down here. Have a great day.